All right, calculus. Section 5.5 introduces a new strategy for integration called integration by substitution, or sometimes referred to as U substitution, since when we do a substitution, the letter U is traditionally used as the sort of middleman variable. Let's start by looking at an indefinite integral. We are going to do both indefinite and definite integrals in this section. So we'll start with the indefinite and then we'll move towards doing definite integrals. And we're going to be solving the definite integrals with the fundamental theorem of calculus part 1, where we use the antiderivative at the endpoints to calculate the value. So anyway, by that I mean if you haven't watched the 5.4 videos, go back and watch 5.4. All right, so this integral is a bit complicated looking. Like, we've got x squared plus 1, and we're cubing it, and then we're multiplying by 2x. Up until now, with what we learned how to do near the beginning of chapter 5 with antiderivatives, the approach we would take to this, our only reasonable approach to this would be to actually cube out this x squared plus 1, right? To expand that, and then distribute through the multiplication by 2x and turn this into a polynomial. However, in this section, we're going to introduce a different strategy that is going to make this easier, and it has to do with differentials and doing substitutions. So what we can do here is see this as a composition of functions. So right here we can see this as a composition of functions, and this right here is our inner function, right? So we have x squared plus 1, and then that whole thing is cubed. So our inner function right there, that's what we're going to have be. We're going to make a substitution with that and call that u. This is not that different from what you do when you're doing the chain rule. Okay, in the chain rule, you also do like a substitution with u as your inner function. So I hope this is like a familiar idea so far. The issue is that this is not just the composition of functions, it also has this business over here, and the question is, well, what the heck is that? What's going on with that 2x? Well, let's explore. Let's say that u is going to be x squared plus 1. What I want to do is I want to convert this integral so that I have u cubed. Instead of x squared plus 1 cubed, I've got u cubed. But the problem is, if I stick a 2x dx on the end over here, then, let me show you what that would look like. Oh shoot, this is meant to be a 2x, and then times dx. Problem is here, now I have different variables. I have u and x, and my entire integral is with respect to x. That's a bit of a problem. Okay, I don't want to have more than one variable floating around. So what I really need to do is simplify this so that I only have one variable. And so I need to, in particular, I need to convert my dx into a du. With u equal to x squared plus 1, I can calculate the differential du by taking the derivative of this with respect to x, which would be 2x, and then multiplying by dx. So now we can see what the 2x is doing. The 2x right there is actually part of the du. So what I can do here is come in here and take these two parts together, the 2x times dx. That over there is going to be replaced by my du. So what I'm doing is with this, I'm going to make a differential substitution. And the differential substitution is going to be supporting my my variable substitution over here that I want to make. So this is what you use to make your variable substitution. So the whole result of this would not look like this. You wouldn't do that at all. Instead, you would do both of these substitutions and get the integral of u cubed du. Okay, and this is called a change of variables. A change of variable. Okay, what we've done is we have taken an integral with respect to x, right? X squared plus 1, quantity cubed times 2x, and then dx. We've taken that, and through doing this variable substitution and the differential substitution, we've taken the entire integral and put it all in terms of u. Not only the integrand is in terms of u, but also the differential has to be du now instead of dx. So these two substitutions together allow us to take this and simplify it. And now this integral, being with respect to u, can be simply solved by just using the anti-power rule. So we'll get 1/4 u to the 4th plus c, right? So there we go. That's the answer to that indefinite integral. However, if we want the answer to the original indefinite integral, all we need to do is reverse the substitution we made and go in there and replace the u with x squared plus 1. And that is the antiderivative of the original integrand that we started with. So there we go. So, and you could check that. Check by differentiating. If you do the derivative with respect to x of 1/4 times x squared plus 1 to the power 4 plus c, you will get, using the power rule, 1/4 times 4, which is going to cancel out. So you'll get x squared plus 1 and then to the power 3, reducing the power by 1. Chain rule will say multiply by the derivative of x squared plus 1, which would be 2x. And then the derivative of the plus c is, of course, plus 0, plus nothing. So we just get the x squared plus 1 quantity cubed times the 2x, which is what we started with. So this whole idea of integrating by substitution is essentially just taking the chain rule for derivatives and then finding a way to do that in reverse. So let's write down the general idea of U substitution, integration by U substitution. You start with an integral, f of g of x. So you have some composition of functions like we had here, but then multiplied by the derivative of g of x. Or perhaps, as you'll see in future examples, perhaps not exactly the derivative, but at least like a constant multiple of that derivative. You'll see. There's situations where it's not exactly g prime, but it's close enough, and we can make it work. So if you're trying to do an integral like that, then what you can do is you can let u equal to the g of x. The du is going to be g prime of x times dx, and then make two substitutions. You'll make your differential substitution here with du, and then you'll come in here and make your variable substitution here with u. And you end up getting the integral of f of u du. And then all you need to do is find an antiderivative for this f and get, that'll be, let's call that capital F of u plus c. And that's where, capital F prime equals lowercase f. And then finally undo the substitution and get capital F of g of x plus c. And that is the value, that is the answer to this indefinite integral. Okay, so let's do some more examples.